So we'll go to the one more problem. So problem runs like this. A point S is in the first quadrant. So you can observe that here the quadrant itself given in the problem. So problem itself is telling it is in the first quadrant. So first quadrant, front view above x y line, top view below x y line. Point S. So I told that whenever given in the problem, it will be in capital letters. So point S is given capital letter, is in the first quadrant, and equidistance of 50 mm. This is very much important. Equidistance of 50 mm from all the three principal planes. From all the three principal planes, draw the projection of the point. Draw all the three views of the point. So here it is in first quadrant given. Second one, equidistance of 50 mm from all the three principal planes. What are the three principal planes? So we got vertical plane, horizontal plane and profile plane. So previous problem we are seeing the profile plane. So these three planes are called as principal planes. So here 50 mm equidistance, that is it is equal, it will have equal distance from all the three planes, that is from HP, VP and PP. So from HP 30 mm, 50 mm, it's 50 mm, and VP 50 mm, and from profile plane also 50 mm, equidistant. So then draw the projections of the point. Then once again he is telling that draw three views. So whenever you are locating three principal planes, so you will be by default drawing three views. Which are the three views? Top view, front view and profile view. So here in case of graphics, it is very much important to read the problem, analyze the problem, and then how will be the solution, and then start with the solution. So reading the problem and analyzing what is given is very much important. So point S is in the first quadrant. So it is already given in the first quadrant. He is telling that it is already, that is in the first quadrant. Then equidistant, very important key words in the problem. Equidistant from all the three planes with a distance of 50 mm. So equidistant, that is very much important. Then draw the projections of the point and also the three views. So once you read the problem, so then we can start drawing the projections. So you will draw the XY line. So here first quadrant, so first quadrant always vertical plane will be above, horizontal plane will be below XY line. Vertical plane above XY line, horizontal plane below XY line, X, Y, VP, HP. So this VP and HP you should use capital letter. Then start drawing the projections. So equidistance of 50 mm from all the three planes. So from all the three planes, the point is in first quadrant. So first quadrant, front view will be above XY line, top view will be below XY line. So somewhere here we can start from here. So draw a vertical projector of 50 mm above, same vertical projector 50 mm below. So since it is in first quadrant, so point given is S. So this is the projector, that is S dash, that is front view. This is projector S, that is top view. So 50 mm, 50 mm. Equidistance from all the three planes. I have fixed two planes, that is 50 mm from horizontal plane and 50 mm from vertical plane. Then I should fix one more plane. So for fixing one more plane, in the previous problem it was given that distance of some distance from that is RPP. So profile plane some distance was given, but here he has not mentioned any distance here. So but he is telling that from all the three planes it is 50 mm. So from all the three planes it is 50 mm. So from this projector what I have drawn, where I fixed the top and front view, I will measure a distance of 50 mm. I will measure a distance of 50 mm. So since it is given that is equidistance from all the three planes, there I will fix my, I will draw vertical projector, that is your x1, y1 line. So 50 mm from profile plane, 50 mm from vertical plane, 50 mm from horizontal plane. I have satisfied all the three conditions. I have satisfied all the three conditions. Already I have drawn two views, that is front view and top view. So only thing is I have to draw, or I have to fix the profile view. So once I fix the your profile plane, that is x1, y1. So here the point is in the first quadrant. Point is in first quadrant. So I draw a 45-degree line in the adjacent plane, that is since the point was in second quadrant in the previous problem. Now here in this problem, the point is in first quadrant. So whenever the point is in first quadrant, so where I should draw the 45-degree line. So one thing you have to remember, always top and front view will be in line. Similarly, the profile view and the your front view will be in line. Always top and front view will be in line, and your front view and profile view will be in line. So that is the principle, or that is fixed always. That point you should always remember. Now I have drawn already the profile plane. Now here is my front view, here is my top view. That is, in this plane I got front view, in this plane I got top view. So I should get the profile view. So always front view and profile view will be in line. Hence in this plane I should get the profile view. In this plane I should get the profile plane. Where, that is what I have to locate. Now how to draw the profile view in this condition? That is, it is a condition where the problem is in first quadrant. Now I know in this plane the profile view I should get. So here I got front view, here I got top view. So here I got one more plane. I got one more plane. In this one more plane, at the intersection of your xy and x1 y1 line, I'll draw this 45-degree line. So in this vacant plane, so here I got top view, here I got front view, here I should get profile view, where that is what I have to fix. This is the vacant plane. So at the intersection of xy and x1 y1 line, I'll draw 45-degree in the vacant plane. Then the rule is same, always, as I told, start from always top view. So this is my top view. So start from top view, draw the horizontal projector until it meets the 45-degree line. Then from there I'll draw vertical projector. It should be above or below. Here I know this is the plane where I should get the profile view. Hence I'll draw the vertical projector. From here I'll draw in this direction vertical projector. Then start from front view. This is my front view. So once again you should move either towards left or right. So here I will be moving in this direction because I know profile view will be here. So I'll draw vertical projector from S dash, that is the front view, here in this direction. So this vertical projector and horizontal intersection of this vertical projector and horizontal projector, that intersection point is my profile view. So that is represented as S double dash. Profile view will be always represented by double dash. So that fixes my profile view. So that is what asked in the problem. Draw all the three views. I have already drawn the top view, front view. Now I have fixed the profile view. So all the three views I have drawn, satisfying with the condition given, that is point is equidistant from all the three planes, that is 50 mm given distance. Next we'll move to the one more type of problem. So here same thing, how will be the problem when it is in third quadrant. So here condition is that problem is first quadrant. So third quadrant, you can see that front view will be above xy line, top view will be below xy line. So this will be front view, this will be top view. When that is the case, whenever the point is in third quadrant, how to draw the profile view? How to draw the profile view? So I'll fix the profile plane satisfying the condition. So if it is in third quadrant, so this will be my front view, this will be my top view. So always top and front view will be in line. Similarly, front and your profile view will be in line. So if it is point is same problem, if the point is in third quadrant, this will be S dash, this will be S. That is top view, front view. So profile view will be here. I'll draw 45-degree line here if it is in third quadrant. If it is in third quadrant. So then always start from the top view, move towards left or right. Then start from the intersection point, move above or below, and start from front view. So intersection you will get the profile view. So here whenever a point is in first quadrant, so I'll get the profile view here. So whenever a point is in the third quadrant, I'll get the profile view in this plane. Just opposite to the first quadrant. Then coming to the one more variety of problem. So here problem runs like this: a point 30 mm behind VP. So it is very much important, given 30 mm behind VP, 30 mm above HP, and 25 mm in front of / behind from LPP. front slash behind from LPP. So keywords LPP, front, behind. Draw the projections and name the side view. So here 30 mm behind VP, 30 mm above HP. So behind VP and above HP. So it is always it is given such that behind VP and above HP. So where will be the point? So just to imagine how will be the which will be the coordinate. It's behind VP. This vertical plane, this behind VP, this above HP. That's what given. So point is in second quadrant. So behind 30 mm here, 30 mm here. So distance is same here. Number given distance is 30 mm behind, 30 mm above. Somewhere here will be your point. So second quadrant is known that top and front view both should be above XY line. Top and front view will be both above XY line. So how to draw the projectors? So I'll draw XY line. I'll draw the XY line. So then first I'll try to fix the top and front view. So here also I should draw the profile view. First I'll draw the top and front view. So measure distance from XY line 30 mm above, then 30 mm in front of V. So since it is both 30 mm behind VP and above HP, behind VP and above HP, both given as 30 mm. So the same point will be, that is your top and front view. So if you draw measure distance 30 mm, locate the projector. So this will be your both top and front view. Since it is given 30 mm behind and 30 mm above HP. Then this fixes your top and front view. So I have to draw the profile view. So for drawing the profile view, so I should fix the profile plane. I should fix the profile plane. So where I have to fix the profile plane? So go to the problem. It says that 25 mm in front slash behind from LPP. So LPP means it is left profile plane. So I have to fix the left profile plane and then draw the profile view. So this is my top and front view. So from this projector I'll move a distance of 25 mm towards left. So towards left direction I'll move a distance of 25 mm. So here whatever it may be given, front, behind, so just look at whether it is given as RPP or LPP. If it is RPP, move towards the right direction. If it is LPP, move towards the left direction. So I will measure distance of 25 mm from this projector. From this projector, there I will fix my profile plane. That is X1, Y1. I will fix my profile plane. So then once I fix the profile plane, so then I can draw the profile view. So profile view I can draw. So here one thing you should carefully observe, that here both top and front view is the same point. Same point represent both top and front view. Hence, so here once again the point is in second quadrant. So when the point is in second quadrant, so to draw the profile view, you should draw 45-degree line in the adjacent plane. I know profile plane should somewhere here I should get in this profile plane. So your front view and profile view will be in line. So at the intersection of your X, Y and X1, Y1 line, I draw 45-degree line in the adjacent plane. Then according to the rule, start from top view, move towards left or right until it meets the 45-degree line and then move above or below. Then start from front view, move towards left or right. Intersection of this vertical and horizontal projector will get the profile view. Now since here in this case both top and front view is same, representing the same point, I'll draw horizontal projector from in this direction until it meets the 45-degree line. So then according to rule, if I move above or below, I cannot move because both front and top is same points. So the intersection of this horizontal projector with this 45-degree line itself is your profile view, that is represented as C double dash. That is represented as C double dash. And here he's telling draw the projections and name the side view. So here the view what we get is called as left side view. The view what we get is called as left side view. Points. So we'll go to the next problem. The problem runs like this. A point A is 20 mm above HP, 25 mm in front of VP. Another point B is 25 mm behind VP and 40 mm below HP. draw their projections when the distance between their projectors parallel to xy line is 0, and also add the right side view only to point B. So as I told in the previous session, so here you should read the problem carefully and then analyze what is the data given and then how will be the projections, and then start with the projection. So here projection of, that is condition of 2 points are given. So point A is 20 mm above HP and 25 mm in front of VP, that is one point. Another point 25 mm below VP and 40 mm, that is behind VP and 40 mm below HP. So projection, that is you have to draw the projection of 2 points. You have to draw the projections of 2 points. Its position is given. Its position is given both with respect to HP and VP. Now to start with drawing the projections, initially you should analyze the quadrant in which the point lies. So if you consider point A, it is given as 20 mm above HP and 25 mm in front of VP. So once you read that above HP in front of VP, so it will be always in the first quadrant. So first quadrant, it is above HP and in front of VP. That means point A is in first quadrant. Then come to the other point. Point B is 25 mm behind VP and 40 mm below HP. That is behind VP and below HP. So this is the condition. So it is behind VP, below HP. Means the point is in third quadrant. So once you analyze where will be the point lying or in which quadrant it lies, the first point is in first quadrant, second point is in third quadrant. So once we know the quadrant, so we will be knowing where will be the top view and where will be the front view. So for first quadrant, so your front view will be above xy line, top view will be below xy line, whereas for third quadrant it is reverse, top view will be above and front view will be below. So once you know this, you can start drawing the projections. So first draw xy line and then start drawing the projections of each individual points. So coming to the first point, so 20 mm, that is below HP and 25 mm in front of VP. So from this xy line, measure a distance of 20 above and 25 mm below. So already know it is point A, so this will be A and this will be A, and since it is first quadrant, so the front view will be above xy line, so hence this becomes A dash, this will be A. Next, you have to draw the projection of the second point. But here one added thing what is given in the problem is that he is telling that that is distance between the projectors parallel to xy line is 0. This is very much important. In the previous problems, a convenient distance was given or distance measured between the points parallel to xy line was given. Now here it is telling problem is running like this: projectors parallel to xy line, so is 0, means distance between the end projectors is 0. That is nothing but the projection of both the points will be in line. That is nothing but projection of both the points in line. In the previous problems, convenient distance was given in one of the problem. In other problem, so the distance measured parallel to xy line was given between the two projectors. But here distance measured parallel to xy line is 0. This is very much important. So since it is 0, both the projectors of both the points A and B will be coinciding. So once that is concluded because of the data given, so from the same point measure distance of 25 mm, so 25 mm behind VP and 40 mm below HP, so 25 mm above xy line, 40 mm below your xy line, so there you get the point B and B dash. Since it is the point is in third quadrant, so the front view will be below xy line, top view will be above xy line. So that completes the first part of the problem. Next, he is telling that add the right side view only to point B. So I have drawn the projection of 2 points, so A and B. So you have to draw the right side view only to point B. So if you want to draw the profile view or side view, you have to fix the profile plane. As already discussed in the previous problem, so you have to fix the profile plane. So if you want to fix the profile plane, you should know what is the distance from your, that is, projector. that is not given in this problem. That is not given in the problem. When the data is not given, you can take any convenient distance. You can take any convenient distance and draw the profile plane. That is what done here. So from this projector, measure any distance what you assume. There you fix your profile plane. That is your x1, y1 line. That is your x1, y1 line. This distance is not given. This distance is not given. So when it is not given, you can assume any convenient distance. So once you fix the profile plane, then you start drawing the projection in order to get the profile view for point B only. For point B only. So here, this is for point B, this is my top view, this is my front view. So already as we seen in the previous problem, so your front view and your profile view will be in line. As top and front view will be in line, so the front view and profile view will be always in line. And point B, so point B is in third quadrant. So point B is in third quadrant. Here I got the top view, here I got the front view. So here in this plane I will be getting the profile view. So this is a vacant plane. So as discussed in the previous session, so here in this vacant plane, at the intersection of your xy and x1, y1 line, I will draw 45-degree line. I will draw 45-degree line. So then applying the general rule, you will be always starting from top view. So starting from top view, that is B, so move horizontally until it meets the 45-degree line. Then vertically down, here we are moving vertically down because, so I know my profile view will be in this plane. So then vertically down, then start from your front view and then draw horizontal projector until it meets this vertical projector. That intersection point is B double dash, that is your profile view for point B only. That is your profile view for point B only. So that's how we can draw the projections when the condition given that the distance between the projectors measured parallel to xy line is 0. Next, we'll move to one more problem, that is problem number 7. Here, though you look at the problem looks lengthy, but solution is very simple. Only thing is that how you read the problem and analyze the problem. So just if you go through the problem, it says that a common point 40 mm below xy line represent not only the front view of 3 points A, B and C, also top view of point C. Next, the top view of point B is on xy line and top view of point A is 50 mm above it. Draw the projections of the points and add right side view of point A only and state the coordinates in which point lie. So very simple problem, very simple problem. So here how it starts with that a common point 40 mm below xy line. So below xy line already it is straight away given. So I do not bother which quadrant it lies. So below xy line, so 40 mm below xy line, so represents not only the front view of 3 points, means that 40 mm what you measure below xy line represents a front view of 3 points A, B, C. We got 3 points. So that one individual point represents all the, that is front view of 3 points, that is A, B and C. Also it tells that the top view of point C, means one projection point will be representing 4 points, that is front view of 3 points A, B and C and also top view of point C. Means 4 projections are fixed directly, that is just measuring 40 mm below xy line. Then further what he says that top view of point B is on xy line. So there also I do not bother which quadrant, he is straight away telling that it is on xy line. I represent it on xy line. And next he says that top view of point A is 50 mm above it. 50 mm above it means above xy line. So once again I do not bother quadrant. So directly, so 50 mm above it means above xy line. So there are 3 points A, B and C. So totally I should have 3, that is 6 views. So all are directly given. All are directly given. So one projection represents 4 views. then remaining 2 are also directly given. So once you analyze this problem, so then we can discuss how to draw the projections. So very important, how to read the problem and analyze what is the data given, and then imagine how will be the solution, and then start drawing with the projections. So coming to drawing the projections, as usual we'll be starting with XY line. Then so here 40 mm below XY line, so directly given. So from one of the point you measure a distance of 40 mm, so that represents 4 views. You should remember. So what are the 4 views? Front views of point A, B, C, and also top view of point C. So point C, both top and front view represent that, whereas front view of 2 points. So from XY line I will measure distance of 40 mm. So locate the projection of point that represents the front view. So A dash, B dash, C dash, front view of 3 points, and also top view of point C. So C and C dash, both top and front view is fixed, whereas front view of 2 points is fixed. Then once you finish this, you show the dimensions of 40 mm from your XY line. Then next it says that top view of point B is on XY line. So we know that always top and front view will be coinciding. So the top view of point B is on XY line. So means on XY line means it will be on XY line itself. So from here I have drawn the projection and I have fixed the point. So this point itself I will get a projection, that is projection of point B, that is top view of point B. So 4 projections are fixed. Then further it says that top view of point A 50 mm above it. So above it means above XY line. I will continue this projection line. So from here I measure a distance of 50 mm. So there I fix the projection of one more point, that is A, that is its top view. So A dash, B dash, C dash and C. So I fix the projection of all the 3 points, that is top view of point A and B, A, B and C, top and front view of points A, B and C. That is first part of the problem. Next it says that draw the projections of the points and add right side view to point A only. Add right side view to point A only means once again I should draw the profile view. Profile view to point only A, that is what? Once again you should be careful while reading the problem. So not all the 3 points, only for point A. So if you decide, or if it has to be drawn the profile view of point A, let's look on point A, that is where is the top view and where is the front view. So coming to the point A, so here it is my top view, here it is my front view. So top view is above XY line, front view is below XY line. So means the point is in third quadrant. Similar to the problem what we saw just now. So since point is in third quadrant, so I know that always top and front view will be in line. Similarly, front view and your profile view will be in line. Means here I got the top view, here I got the front view, here I should get the profile view. So before drawing the profile view, I should fix the profile plane. Once again, what should be distance between the projector and the profile, that is plane, is not given in this problem. So in such cases, once again you can take any convenient distance. So from this projection line, I will measure a certain convenient distance. There I will fix my profile plane. So naming is done as x1, y1. I know top is in this plane, front view is in this plane. I should get the profile view in this plane. So this is the vacant plane. So whenever you draw the profile view for third quadrant, when the point is in third quadrant, you should draw the 45-degree line from the intersection of x, y and x1, y1 line from the intersection point in the vacant plane. So that's what done here. So this is the intersection point of x, y and x1, y1 line. So from here you draw 45-degree line. So in this vacant plane. Then the common rule, once again, in order to get the profile view, start from top view, move towards left or right depending upon the condition, then until it meets the 45-degree line, then move above or below, then start from front view, once again move left or right until you get the intersection point. That is the common rule that should be applied in order to get the profile view. So applying that rule in this condition, so this is my top view, A. So I have to draw the profile view to point A only. So from here I'll draw horizontal projectors. I'll draw horizontal projector. So in this direction, this arrow mark shows the direction in which the projector is drawn. So it meets the 45-degree line at this point. Then from here I'll draw vertical projector. From here I'll draw the vertical projector. This arrow is the direction downward. So then start from the front view. A dash is here. This is the front view of point A. So draw horizontal projector until this meets the vertical projector. The intersection of this vertical projector and horizontal projector will be your profile view, that is represented as A double dash. That is represented as A double dash. So you'll get the profile view for point A only. That is what given in the problem. That is what only given in the problem. So I drawn the projections of point A, B and C. So top and front view for all the 3 points, and then profile view to point A only as per the conditions given in the problem. So further, so he has also asked, state the coordinates in which points lie. State the coordinates in which the point lie. So look at each individual point. Look at each individual point. So start with point A. So point A, so top is here, front view is here. That is top view is above XY line, front view is below XY line. So whenever we get the top view above XY line and front view below XY line, so as discussed in the previous sessions, so that is nothing but the condition when the point is in third quadrant. So hence point A is in third quadrant. Then come to the second point. So coming to the second point, so point B is on XY line. Point B is on XY line. That is your top is on XY line, front view is below XY line. So top is on XY line and front view is below XY line. So in this condition, so it can be either the point can lie in 2 of the quadrants. It can be third quadrant or fourth quadrant. So top is above, top is on XY line and front view is below, that is your XY line. So if you consider this given condition, so here the point B is on here, that is horizontal plane, and this is the condition where point B is 40 mm below. So 40 mm below. So you can assume, since it is on, since the point is on XY on your vertical plane, if I consider it is here, then it becomes third quadrant. If I consider the point to be here, then it is fourth quadrant. Since it is on VP, so either it can be third quadrant or it can be in the fourth quadrant, because it is just given as it is on vertical plane. Whether in front or in behind, that is not mentioned. If you consider front, then it will be in one quadrant. If you consider this is in the front, then it becomes fourth quadrant. If you consider behind, then it will be the third quadrant. Hence point B can be either in third or fourth quadrant. Then come to the point C. So here point C, you can see that both top and front view is below your XY line. Both top and front view is below XY line. So we can get this condition only when the point is in fourth quadrant. As discussed in the previous sessions, so whenever point is in fourth quadrant, so both the points, that is both the top and front view will be below XY line. So this is the fourth quadrant. So this is the fourth quadrant. So somewhere point is here. When the point is here, the rule says that the horizontal plane should be rotated clockwise, vertical plane is fixed. So here both top and front view will be in this plane. If I rotate like this, both top and front view I will be getting below your XY line. Then this is the intersection of your horizontal and vertical plane is your XY line. Since it is both top and front view below XY line, so quadrant is fourth quadrant. So this is how we can solve the problems by reading the problem and analyzing what the data given, and then move on with the drawing the projections. Thank you.